This lesson will uncover various MQTT publish message sequences, highlighting MQTT's message transport options, referred to as quality of service or QoS. MQTT provides 3 publish message sequences, which represent 3 delivery assurance levels. Quality of service level 0 or QoS 0 is also called at most once delivery or fire and forget. Quality of service level 1 or QoS 1 is called at least once delivery. And quality of service level 2 or QoS 2 is also called exactly once delivery. We'll cover each of these published sequences in more detail. Since data loss can occur due to an inadvertent TCP disconnection, MQTT provides message transport service levels on top of TCP. QoS is a key feature of the MQTT protocol. QoS gives the client the power to choose a level of service that matches its network reliability and application logic. Because MQTT manages the retransmission of messages and guarantees delivery, QoS makes communication in unreliable networks a lot easier. QoS delivery assurances in MQTT are concerned with delivery between a sender and a receiver. So there are 2 cases that present themselves. There's message delivery from the publishing client to the broker, and then message delivery from the broker to the subscribing client. For end-to-end quality of service, you need to consider both sides of the message delivery. We will look at the 2 sides of the message delivery separately because there are subtle differences between the 2. The client that publishes the message to the broker defines the QoS level of the message when it sends the message to the broker. The broker transmits this message to the subscribing clients using the QoS level that each subscribing client defined during the subscription process. If the subscribing client defined a lower QoS than the publishing client, the broker transmits the message with the lower quality of service. In the example that's shown here and in the subsequent slides, the subscribing client subscribed to the topic with a QoS level of 0, as indicated by the lack of a pubback message between the subscribing client and the server. Let's take a closer look at each of the published message sequences available in MQTT to see how QoS delivery assurance is implemented. Here we see the published message sequence for QoS 0 delivery assurance. The publishing client, who is the sender, sends the message, then immediately deletes it. QoS 0 relies on the transport capability of the underlying network, which in our case is TCP, to reliably deliver the message. You should use QoS 0 if you have a completely or mostly stable network connection between the sender and receiver, if your application can tolerate occasional lost message, or if you don't need message queuing, which is available in a QoS 1 or QoS 2 delivery assurance level. Here we see the publish message sequence for QoS 1 delivery assurance between a publishing client and a broker. In QoS 1, the message is always delivered at least once. If the sender does not receive an acknowledgement, the message is sent again with the duplicate flag set until an acknowledgement is received. As a result, the receiver can be sent the same message multiple times and might process it multiple times. The message must be stored locally at the sender and the receiver until it is processed by the receiver. The message is deleted from the receiver after it has processed the message. In this example, once the broker publishes the message to the subscriber, it deletes the message and sends a pubback acknowledgement to the publishing client. The message is then deleted from the publisher client. You should use QoS 1 if your application needs to get every message and can handle duplicates. If your MQTT implementation supports it, QoS 1 is the most frequently used service level. or if your application can't bear the overhead of running a QoS2 service. QoS1 delivers messages much faster than QoS2. Here we see the publish message sequence for QoS2 delivery assurance. This is the highest quality of service for use when neither loss nor duplication of messages are acceptable. It is provided by at least 2 request response flows between the sender and receiver before the message is deleted from the sender. In the first pair of transmissions, publish and pubrec, the sender transmits the message and gets acknowledgement from the receiver that it has stored the message. If the sender does not receive an acknowledgement, the message is sent again with a duplicate flag set until an acknowledgement is received. In the second pair of transmissions, pubrel and pubcomp, the sender tells the receiver that it can complete the processing of the message via the pubrel message. If the sender does not receive an acknowledgement of the pubrel message is sent again until an acknowledgement is received. The sender deletes the message it saved when it receives the pubcomp acknowledgement to the pubrel message. The receiver can process the message in either the first or second phases, provided that it does not reprocess the message. If the receiver is a broker, it publishes the message to subscribers. If the receiver is a client, it delivers the message to the subscriber application. The receiver sends a completion message back to the sender that it has finished processing the message. Once the publishing client receives a pubcomp message, it can delete the message because it knows it has been successfully transmitted. So where should you use QoS2? So you should use QoS2 if it's critical that your application receive messages exactly once, if your application can handle the overhead of QoS2 delivery. Note that many MQTT implementations do not support QoS2, and we'll see with Adafruit, they support up to QoS1 for their MQTT service. So to summarize, the quality of service between 2 MQTT clients that are connected to a broker is determined by the QoS of the published messages and the QoS of the subscribing clients. The overall QoS is always equal to the lower of these two, as shown in this table.